Okay, the next one, we're talking about gravitational force. So gravitational force, what is it about? It's actually the force of attraction between two masses. What does it mean? As long as two objects has mass, they will attract each other. Okay, this is something interesting, which means that if you stand beside a person, okay, for example, you and your friend, when you stand beside each other, there's a gravitational force between both of you guys. Okay, as long as you have mass, there's a force of attraction. We term it as gravitational force. So some example is people standing on the ground. You are attracted to Earth. But in the same way, Earth is also attracted to you. Oh, this lies in the question. Okay, Earth and you attract one another, but you know why the Earth doesn't move, or why don't you feel the attraction? Because the Earth is too big to feel your force of attraction. Okay, the other thing is this. Objects are falling downwards towards the Earth is because of gravitational force. So just take note of these two. Okay, the examples of gravitational force. So now, as you can see here, why don't the two people fall off from the Earth? You can see a person here, a person here. Why do they not fall out? Because gravitational pull is present. Okay, the gravitational pull is actually the weight of the two person. Where does it pull towards? It is towards the center. There's a red pen here. Towards the center of the Earth. Everything pulls towards the center of the object. Okay, we call it the center of gravity. So just take note of this term. Okay, center of gravity. Another thing is this. The Earth is surrounded by air, but why doesn't the air float out into space? Because air has mass too. This is something that we always forget. It's so light doesn't mean that it has no mass. Okay, so air actually has mass, and hence it has a weight. As long as you have mass, you have weight, so the air will be attracted towards the center of the Earth. Okay, all attracted towards the center of the Earth. You got a whole region of air over here, and it's all attracted towards the center. Okay, center of the Earth. It's a red. Okay, center of the Earth. So this is why the air doesn't float out into space. Okay, so as you can see here, two more effects of actually your gravitational force is your tide and is your weight. Okay, weight we keep mentioning. So your weight is because of gravity. So what is actually weight here? We always talk about weight and weight and weight. What's the difference between weight and mass? Okay, this is a question that's in your mind now. Now, weight is actually a force. So just take note, weight is a force. Okay, it is the gravitational force acting on an object. Okay, gravitational force acting on an object. So because it's also a force, it's measured using a spring balance. Take note, we have some calculations here. Okay, to calculate the weight of an object, we use the mass multiplied by the acceleration. So for example, Mr. Eugene has a mass of 80 kg. He's a heavy man. So what is his weight? So to calculate his weight, what you do is you take his mass in terms of kg, you multiply it by the acceleration due to gravity. In this case, it will be Earth. For the g of Earth, you all should know that it is 10 meters per second square, or sometimes 10 Newton per kg. Okay, so 80 times 10. So my weight is actually 800. 800 was the unit newtons, because weight is a force. So take note, when you do some simple calculations with regards to this formula, the weight must be in newtons, the mass must be in terms of kg, okay, and g, it depends. Okay, for Earth it is 10. This is for Earth. Okay, for moon, g is equals to 1.6 Newton per kg. Okay, this is for moon. Okay, g can represent for Earth, g can represent for moon. It depends. Sometimes they'll write things like this: g moon, g Earth. It means means that is the gravity of moon. Okay, this means gravity of Earth. Okay, so don't be too shocked when you see such symbols. Okay, now this is with regards to the using the formula W equals mg. So as you look at this formula over here, you realize this: the greater the mass, the greater the mass, the greater the weight. So a person with higher mass will obviously have a higher weight. The other thing is, the greater the gravitational force acting on an object, the greater the value of g, okay, the greater the value of g, the heavier the object is. So the greater the weight. So different planets have different gravitational force. So you must remember this. Okay, example. Earth, Mars and Moon all have different gravitational acceleration. So Earth has the greatest gravitational acceleration, followed by Mars, followed by the Moon. So will we have the same weight at all three places? We have the same weight. Take note. W is equals to mg. So if all of them, the value of g is different, okay, Earth is the greatest g, Mars is the middle, and Moon is the lowest g, so obviously the weight is different. So this will be the, so you can see that the weight will be the biggest for this. Okay, weight on the Earth will be the highest. Okay. Then followed by the weight is actually the lowest on Moon. So if you want to say that you weigh very light, where do you go to? You go to the Moon. And you'll be floating around, you'll think that you're very light. But truthfully, weight is not a good measure of how heavy we are. Okay, because it depends on gravity. Now, so what we normally use to measure ourselves is actually this thing called mass. Okay, mass. Mass is in terms of kg. So whenever we go onto the weighing machine, we step up there, the value that we see is actually the mass. Okay, when I say I'm 80 kg, that's actually my mass. Okay, because the value, obviously you can see that the units itself is already different. If you see the units is in kg, that's your mass. If you see the units is in Newton, most probably it's a force, and if it is your force, it is the weight. So now, let's take a look at some of the differences. Okay, weight is actually the gravitational force acting on an object. Okay, gravitational force acting on an object. Whereas for mass, it is the amount of substance. It is the amount of substance in an object. Okay, so one is a force, one is the amount of matter. So take note of this difference here. Next one, the SI unit is different. For mass, it is in kg, whereas for weight, the SI unit is in newtons. So the key difference here is also the SI unit. Next one. For force, or I should say, okay, spring weight is a force. Okay, it is measured with a spring balance, as we have discussed just now. Whereas for mass, we actually measure it with a beam balance. So this is actually how a beam balance looks like. So spring balance over here, beam balance over here. So you can see three key differences between weight and mass. And the last one, okay, weight varies according to location. Okay, I should say that, let's not write this down. We say that weight varies according to the acceleration due to gravity. Okay, this is actually a better way of saying it. So you go to different planets, okay, your weight changes because the acceleration due to gravity changes. Whereas in this case here, for mass, it does not change according to location. It is a constant. So you can say mass is constant, because obviously it's the amount of matter contained in an object. So unless you go, maybe for example myself, if I go and shit, okay, when I go and poop out all my bowels, release my bowels or whatever, okay, I'm actually losing mass. Because if I lose mass like this, my mass changes. But that's only a few things that can cause your mass to change. Whereas for weight, it's very easily changed. Go to different planets and your mass and your weight will change, because the acceleration due to gravity is different. So just take note of this last part here. We talk about gravitational force is a big thing. Because of gravitational force, we have this phenomenon called weight. Without gravitational force, no such thing as weight. So this is the end for the third type of forces, which is your gravitational force.